Hello everyone. Let me know if I'm audible. Okay. And let me know if the screen is also visible. Let's wait for a while and then we will begin. Okay. So let's start. Let me give you my introduction. So currently I'm working as a software engineer at Inference Labs. Previously I worked with ClearText as an SD1. I was also an intern at Red Hat and I was the ACM ICPC 2019 regionalist, and I have quite some like 1+ year teaching experience as well. The subjects that I will be taking are DSA in C++ and interview preparation. So now let's come at this career as a developer subscription. So over here, like it's for people who are on their path to become a software developer or are already or have just started their career as a software developer. So Unacademy brings you this platform where you can get access to weekly shows, and it will be around placement in top product or service-based companies. Like problem solving will be there, and over the weekend project will be there. So basically in it, you will get the hiring updates about major tech companies and startups around there and how to apply to them, right? And there will be like HR talks as well, where HR from big companies will be coming and giving their talks like what hiring procedure is all like, right? And good companies or working in Pang, they will be coming and sharing their experience as well, and many more like that. Okay, so this all thing comes under this career as a developer subscription, and you can, and it's for just 99. You can use my code Spartak10 to get 10% off, and you can get it in 899, right? Then this is as I told you, like this is the college project, so it will be taken Striver, and it occurs at Friday night at 10 p.m. Okay, so basically when we are in college, so in third year, fourth year, so we are having our minor and major projects, right? So at that time, like if you're not aware about how to pick up a project and what to do or what gaps are there, so he will be helping you out to fill those gaps and that you make a good project around there as well. Projects are very important when you are going for placements or internships, so it will be a good way to just have a good project. Okay. And this is the Coach Chef Apprentice program. So it's already started on 14th of August, and it's taken by Sai Avinash, who is an SD at Google and is a 7-star at Coach Chef. So he's among India's topmost competitive programmer. So you will be in this every Saturday afternoon at 2 p.m. So he takes the shows, and you will be able to lively interact with him and even suggest a problem on which you are stuck, and he will be solving it, and you will be getting to learn how to solve a problem and upskill your competitive programming skills. Okay. So do like, share and subscribe, as you will be able to get the notification classes and everything as well over here, and you won't miss any of them, right? And we have an Unacademy channel as well, where we have maximum score after splitting binary string. Both are of easy level, but both are easy level, but it will be very helpful, and the concept behind them is also very helpful. If someone who is new to programming, at that time it will be like really helpful to you. Okay, so let me know if I can begin now and go to the problem statement. So basically this whole session will be like, I'll be reading the problem and will tell you, like, if you encounter a problem in interview, so how you will be solving that, what should be your thought process, and how you should present your solution, right? Okay, so let me start with it. Just write a yes or no if I can begin. And try to be like interactive, because live problem solving is of no use like if you don't interact and tell your solution, your approaches, and I would be discussing them. So it will be a fun thing if we could interact and solve the problem together, right? Okay, so let me start with the first question. So the question is that we are given an array of integers, which is nums, and we have to calculate this pivot index of this array. Okay, so let us understand what this pivot index is all about. So pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all numbers strictly to the index right. Okay, and if the index is on the left edge of the array, then the left sum is 0, because we won't be having any elements on its left, right? And if there are no elements like for the right edge of the array as well, we won't be having any elements on its right, so we'll be taking the sum 0 only. Okay, and if suppose we are having multiple such indexes which are the pivot index, okay, so we have to just return a -1 if we don't find an index, and if we have multiple of them, then just return the leftmost pivot index. Okay, so let me take the sample example, right? Let me take a sample example. So this is our 173656 is our sample array, right? So we have to find an index on this array such that the sum of elements on its left and on its right are equal, right? So suppose we started at index 1. Okay, over here let's take a 0 based indexing. Okay, 0 1 2 3 4 5, right? So if we are here at the 0th index, so it's the left edge of the array, right? So we won't be having any elements on its left, so the sum is 0. So over here the sum is 0, and on its right the sum is this whole, right? 7 plus 3 10 16 21 27, so 27 is the sum. So 0 is not equal to 27, so obviously 0th index is not our pivot index, right? Now let us come to this index 1. So if we are at 1, the left sum is 1 and the right sum is this 6 plus 3 9 plus 5 14 plus 6 20, so 20 is the sum over here. So obviously the 1 and 20, these are not equal, that is the sum on its left and right, so it's not a pivot index, right? Now similarly we come over here at index 2 and we see the sum on its left and on its right. So over here, the sum on its left is 8 and on its right is 17. So still it's not equal. Now we come to index third. So over here, the sum is 7 plus 3, 10 plus 1, 11. And on its right, it's 5 plus 6, 11. So if we notice at third index, okay, at third index, the left sum was 11 and the right sum was also 11. So yeah, this is the first index which is the pivot index or the required index. So we will stop as soon as we find the first index, because we have to return the leftmost pivot, right? So for this, the output is 3. Similarly, if I take the second example, so it's 1, 2, 3. So if you come over here, the sum on its right is 5 and over 0, so not a pivot index. 1, 2, then 1 and 3, not a pivot index. Over here, the sum is 3 and over here is 0. We don't have to include that index, okay, on which we are there. We have to exclude that index and see on its left and right. So we traversed the whole array and we didn't find any pivot index, so we will be returning -1, right? Because there is no index that satisfies the condition. Now let us look at this as well. 2, 1, -1. So if we are over here, the sum on its left is 0. Now the sum on its right, 1 minus 1, it's also 0. So this is our required index and we will return 0. And we have to return the index in zeros, like it is 0 based indexing. So we have to return in terms of that. Let me know if the question is clear to everyone. Let me know if it's clear. Then I will move ahead with the solution and how we should approach it, basically. Okay. Let me know if I can start with the discussion of solution, and like we will go in such a way as we will be answering the similar problem if we encounter in an interview. Okay. Okay, so let me start now. So first of all, we should focus on the correctness. We left second index and calculate right side values. Yeah, like Pramod, like if we are at an index I, right? So we have to exclude that index and we have to see the sum on its left and on its right. And if they are equal, then this ith index is the pivot. Okay. Is it clear? Okay, cool. So let me start with the brute force solution. So whenever you encounter any problem, okay, so first try to think of a brute force solution, because correctness is very important. Okay, then we should go for optimization, right? So over here, suppose if I am given an array a1, a2, a3, okay, till an. So what is the first approach that comes to our mind? And that is, if I am at index I, suppose over here, if I could traverse till 0th index, and like from I minus 1 to 0, and from I plus 1 to n minus 1, if I can get this sum from here, and if I can get this sum from here, and if I compare it, right, if I compare it, and if it comes out to be equal, then yeah, this is my index, right? So if I write the pseudocode for the same, so suppose I start from I equal to 0 and I go till n. So initially I am taking sum left right? So since we are starting and sum right, sum right, so both we shall initialize as 0. Okay, so if I come over here, now I'm at this index, right? I equal to 0. So I will go to left. I will say while I will denote it. I will take a variable, and for left I will go over here while j is greater than equal to 0, and I will simply store my left sum over here. Okay, equal to ARR of 5. So this will for a particular index I, it will give me the total sum which I can get from the left part of it, excluding the ith index, because that's why you started from I minus 1, right? Now similarly I will take from right. Okay, so I will initialize my j to I plus 1, and I will say get me the sum from its right side. So while j is less than n, and I will take the sum equal to ARR. So now what we have to just do, we have got our sum from left and we have got our sum from right. Okay, so what we have to just do, we have to just compare. If sum left is equal to sum right, okay, so we will just return from our function, or we will break, or we will see that okay, this ith index is our answer, right? So if you can see, this will take n time, okay, an operation. In worst case, suppose if I am at index j, or it will take n minus I times, right? And this loop will also take n minus I times. Okay. So if I consider the time complexity for the same, okay, so what it will be? It will be n minus I, okay, plus n minus I inside, and how many times it's running? It's running basically, it's running n times. So if I see, it will be somewhere around n square, okay. It will be, or the big O complexity will be n square. So obviously it's not a good approach, and the space complexity, since we are using only 2 variables, so it will be big O of 1, right? So this is the brute force solution. Let me know if the brute force solution is clear to everyone. It's very simple. It's an easy problem as well. Okay, right. So now it's big O of n square, okay, big O of n square. So if we are having an array, suppose if the size of my array was of order 10 to the power 5, so this will give me a TLE, right? N square approach would fail over here. Okay, this big O of n square approach will fail, and it will give me a time limit exceeded. So now our thing is, can we think of an optimization over here? Can we think of an optimization? So one way, or one thing, if I take a simple example from here, 173656, okay, if I take this example, 173656, okay, if I take this example, can I say that if I am at ith index and in constant time, I can get the sum on its left and sum on its right, okay, then I have to just iterate over an element one time, and I can do it in linear, or like I can do it in big O of n in a single traversal, right? Whatever we were calculating sum L and sum right, if I can get in a constant time, okay. So for doing this, we can think of a clever approach, that let's calculate the total sum of array. Okay, let's calculate the total sum of array, right? So the total sum for this array will be 7 plus 1 8 plus 3 11 17 22 28. Okay, so our total sum is 28, right? Now this was our let me just write down the array again. Okay, so this was our array and this is our total sum. Now suppose I was at index 3. Okay, I was at index 3. Hi Rohit. I was at index this, that is the second index, at third having the element 3. Okay, so if I am traversing, if suppose I am traversing from I equal to 0 to n. Okay, if I am doing this, so can I say I can store the sum of my left side till I by simply doing sum L plus equal to ARR of I? Can I say that? For example, if I am here, then my sum L, I would have traversed till this point, so I can simply calculate the sum till here. So my sum L I can simply get as 8. Now the clever part is over here, to get the sum on its right side, okay, what we can do, we can if my total sum was 28 and if I subtract the sum till here, subtract this sum, then I will be getting the sum or the remaining sum on its right side. So can I say that I can, at a particular index I can get the sum on its right at t sum minus sum L plus that index, right? And I have to simply compare this, that if sum on its left and sum on its right are equal, then simply just break over there and that ith index will be our required pivot index. Okay, so let me just write pseudocode for it. We will be taking the same variables, sum left and sum right equal to 0. Okay, and now just loop round to calculate total sum. Okay, total sum. So we will have another variable as well, t sum. Okay, so we will be going from 0 to n and t sum will be, we will just calculate the t sum similarly by taking the cumulative sum. Okay, now comes our logical part where we have to do that thing, the algorithm which we discussed just before. So over here we will start from I equal to 0 until n. Okay, and before we arrive, like we have arrived at its ith index, right? So over here we will check my sum L is 0 right now. Okay, so I have to calculate sum right. So it will be total sum minus sum L plus that ith index. Okay, plus ARR of I. So it will be, so suppose I am having this array, I am having the total sum. Okay, I am having the total sum, I am at this index. So to get the value on its right, it will be t sum minus its left, like whatever is there on its left side, right? So this is what we are doing over here, and we have to just check if sum L is equal to sum right. Okay, then just store your answer. Let's take a variable as answer and we will initialize it to -1. Why -1? Because if if we don't get any of the index, so we have to return -1, right? So we will take it -1. And if I have got any index, which, and since we are traversing from left, so obviously if the first encountered index will be the leftmost one, right? So our answer will be I, and we will simply break over here. Okay, and we will simply return answer. Okay, so over here, if we look what we optimized, how we optimized, whatever we wanted to get the sum on its right and left, we are getting now in constant time, right? In constant time. Now there is one thing missing over here. We haven't updated our sum on left, because we have to carry forward our sum left whenever we encountered a element I. So we'll keep on updating our sum left. So sum left will be equal to ARR of I. Okay, so this is the complete code. So every operation inside this will take a constant time, and this loop will run for n times. So the complexity comes out to be big O of n. So we moved from O(n) square approach to big O of n approach. Let me know if it's clear to everyone, and then I will code the solution. Let me know if the approach is clear, and if you get like, okay, how to think of an optimization, like if you have find out the brute force approach and it's correct, then how to think like, okay, on what aspects we can optimize it further, right? Rohit, I didn't get you. Okay, so let me just code the solution for you. So this will be our array, and we have input the array, and this will be our answer, and we will call a function find pivot. Okay, and what we will be passing, we will be passing nums and n. Okay, the return type will be of int, because we are returning an index, and it will be of integer type. We'll call our function find pivot, and nums 10. Okay, then what we have to do, we have to declare our variables. So what this, sum L to 0, sum right equal to 0. So firstly we'll take the total sum. Okay, we'll be taking the total sum. So here we have got a total sum, right? Now comes the algorithm which we have discussed. So let's see. So I am at the first index. Okay, and this approach will even handle your edge cases, that is if you are on the first index of the array or on the last index. Okay, because like suppose you are on the last index, so you will be subtracting the whole sum on its left, so you will be remaining by zero sum, that is the whole array sum. So it will handle that as well, right? Now let's come over here and do our thing. So over here we had to calculate sum right for each index. So sum right will be t sum minus sum on its left plus that current index. Okay, and if sum L is equal to sum R, then we will simply return I. Okay. Else, like if we didn't find, we will be going to the next index and we'll simply update our left sum. Okay. So left sum will be nums of I. Correct? Is it clear? And if suppose my loop ended and there I didn't find any of the pivot element, so what I will simply do, I will simply return a -1. Okay, and over here let's print the answer. And note one thing, like whenever you are asked any question to code in an interview, just follow the modular structure. Always make a helper function, separate helper function. Don't just like club everything in your main function. Okay, you should have separate function for whatever operation you are performing. So now let's see what was our first array. So our array was 173656. Okay, so size was 6. DSA with C++, it will be soon starting. Right now I am taking up these interview series problems. It will help you a lot, like how to approach a problem and what is the right way to deduce a solution in interview. Okay, so our array was 173565. Right, 565. Now let's run and see if it's running fine. Okay, so our answer is 3 and we wanted it only, that is this 5th index. Okay, the element having 5, this 3rd index. So it's giving the, now let's see an example where there is no pivot index. Let's see that as well. 1, 2 and 3. Yeah, 1, 2, 3, right? So it should return -1. Let's see. Yeah, so we didn't find any of the index, that is pivot index, so we are returning -1. Let me know if this question is clear to everyone. So we have optimized it completely, like this is the best approach which we can follow for this problem, and its time complexity was big of n and space is constant only, big of 1. So let me know if it's clear to everyone. Then I can move ahead to the second question. Okay, so I am assuming that everyone has got it. So the second question like is also a similar kind only, but it will be good like if you have learned this concept and if you can apply to the second question. Okay, so let's move on to our second question. Okay, let me know if it's good to go. Okay, so let me start. And guys, like please try to be interactive, because this session would be not very much useful if you are not thinking of an approach and validating it. Okay, and try to solve the problem alongside with me. Okay, so let me begin with this problem. So the question says we are given a string S and it consists of zeros and ones. So basically it's a binary string. We have to return the maximum score after splitting the string into two non-empty substrings. Okay, two non-empty substrings, that is left substring and right substring. Okay, the score after splitting a substring is the number of zeros in the left substring plus the number of ones in the right substring. Okay, so what the question like wants to say is, we are having a binary string. Okay, always when you read a problem, try to reduce the problem in a simpler format in your own terms. So if I try to reduce this problem, okay, if I try to reduce this to a simpler problem, or so what can I say? I am having a binary string and I have to calculate the maximum score. And what is the maximum score? That I have to split my string into two non-empty substring. Okay, so basically I have to split my string into two halves such that the score is maximum. And how we are calculating the score over here? That is the number of zeros in its left substring plus the number of ones in the right substring. So can we say that if I am dividing the string at any half, suppose this is my string and it is having characters C0, C1, C2, C3, C4, C5. Okay, and this is a binary string. So binary string, what I mean is it will contain only zeros and ones, right? So what I mean by dividing the or splitting the string into two non-empty substrings. So first of all, substring, what do you mean by substring? So substring is continuous part of the string. Okay, continuous part. It cannot be like this C0, C2. That's a subsequence. Okay, substring should have consecutive elements. Okay, okay, so what we basically want to do is, we will try to whenever there is a string, so first thing which comes to my mind is I will try to break my string into all two halves that are possible. Okay, so just give me a second. Yeah, so firstly I will divide over here. So C0, C1, C2, C3, C4, C5 is my second half. Similarly, I can divide over here as well. So my first half will become C0, C1, these characters, and C2, C3, C4, C5. Okay, so similarly I will be breaking it in all the possible two halves, because we want two non-empty, okay, can't be an empty, two non-empty substrings, right? So now let's take a simple example over here. Let's take a simple example. So this is our example, that is 0, 1, 1, 1, 0, 1. So I will try to divide it into all possible two halves, right? And we will calculate the max score. Let me write over here. Our max score is calculated by, I'm denoting by this. L0 means number of zeros on its left plus R1s, that is number of ones on its right. Okay, so now over here, if I divide my string over here, okay, I divide my string over here. So this is the left part and this is the right part. Okay, so my max score is 1 plus 4, that is 5, because we are having 4 ones over here and 1 0 on its left side. Now if I divide my string over here, okay, over here, so my left part is this and my right part is this, correct? So how many zeros are there in its left? It's 1. And how many ones are there on its right, like on the right substring? These are 3. So 4 is the maximum score if I split the string in this manner. Now if I divide the string over here, okay, so 0 1 1 will be my left substring and 1 0 1 will be my right. So over here 0 1 1, so 1 0 is there, number of zeros on its left, and number of ones on its right are 2. So my answer is 2 plus 1 equal to 3. Now if I divide my string over here, 0 1 1 and over here basically, and my right substring is 0 1, so number of zeros on its left is 1 and on its right is also 1, so 2 is my answer, right? And if I finally divide my string over here, so my left part will be having 0 1 1 0 and the right will be having 1. So number of zeros on its left is 2, this 0 and this 0, and number of 1 on its right is 1. Okay, so basically my answer is 3. Okay, now by splitting we have made all the possible split on this string. Now what is the maximum value? What is the maximum value out of all these values? 5 4 3 2 3 5, right? 5 is the maximum score that is achievable if we divide the string over here, okay, this part to this part and this part. So 5 is our answer. Let me know if the question is clear to everyone and you all have got the like how we are like splitting the strings and how the answer came out to be 5. Okay, so as usual we will first start with the brute force solution. Okay, so can anyone give me the brute force solution for the same? If we have solved this first question which we discussed just before this question, then you will be able to relate it. It's a variation of it. Okay, split in all possible ways and then calculate max score. Okay, yeah, so splitting in all possible ways, and we have to basically after each split we have to get what is the number of zeros on its left and what is the number of ones on its right? So let's do it. So let's take count L0, that will be storing the number of zeros on my left, and count R1, that will be storing the number of ones on my right. Okay, and since it's a binary string, okay, it's a binary string, so I will be going from, let me take the size of the string as n equal to s dot length. Okay, in CPP we use dot length function to get the size of the string, and we will be starting from I equal to 0 to n, right? Now over here in previous problem we had to exclude that particular index, but over here since we are splitting our array, since we are splitting our string into two halves, so we have to consider all the elements. So I will take this 0 1 1 1 0 1, this one only, and I will take this 0 1 1 1 0 1. So this is my left substring and this is my right substring. Okay, so I have to calculate the number of zeros on its left. So how will I do that? So for each index I have to initialize this as 0 because we will start in a new format for every particular index, and let's denote j equal to I. Okay, and now we'll go to left and calculate how many zeros are there. Okay, and similarly for right as well, it's number of zero or number of ones on right. Okay, so we'll loop from j, okay, while j is greater than equal to 0, and we will see if s of I is equal to 0, because we only have to focus on number of zeros on left. So we will simply increase our count of count L0 plus, okay, right, and we will get the number of zeros on left. Now similarly for getting the number of ones on right, okay, number of ones on right, what we will do, I will start from j equal to I plus 1, right, because if I am taking C0, C1, C2, C3, C4, so if I am at this index, so till this is my left and rest is my right. Okay, so from j equal to I plus 1, and we have to calculate number of ones on its right, so it will go to j less than n, and if s, it's sj. Okay, if sj is equal to 1, because we have to on the right side we have to only focus on how many number of ones are there, right? So we have to just increase our count of right on ones, correct, and here we got both are values which are required, right? How many zeros are there on left and how many ones are there on right. Okay, now we will take a variable which will be storing our answer. Let's declare it as answer only, and initialize it as 0. Okay, because minimum score can be 0. If it's an empty string, then the minimum score will be 0, right? So now over here what we will do is, we have got this count R1 and count L1. I will store the maximum value for every index which I have encountered. Okay, so it will be count left 0 plus count right 1. Okay, yeah, keeping maximum value exactly. Okay, as such and things, and what we'll do, we will simply return this answer. Okay, so over here if we look closely, okay, if we look closely, this operation is taking n times, this will be again taking n minus ith time. Okay, and similarly for this it will be taking I time. So I, if my I is equal to 0, like it will also take n minus I time, right? Okay, so if my I equal to 0, then I have to traverse from I equal to 0 to n for the whole thing. So it will be on a rough basis, it will or if we exclude the smaller aspects of this, how j decreases for 0. Okay, yeah, right. So over here we have to do j minus minus as well. Thanks for pointing it out. And over here we will do j plus plus. Okay, so this will be taking n. So what I can say is it will be again something n and n plus n inside in worst case. So it comes out to be n square plus n square, and it will be big O of n square. Okay, in worst case. So the time complexity is this, big O of n square. And as we discussed earlier, so if suppose my string, my length of this string, I will denote by mod of s, is of order 10 to the power 5, then it will give a TLE. The solution will fail. Okay, So now again our job is to think of an optimization, right? So we have to think of an optimized approach. Our array was 0 triple 1 0 1, right? This was our string. This was our string, correct? So over here, if you have focused on the last problem which we discussed, can we use something like that? The biggest advantage over here is initially, I guess, count the number of zeros and ones by traversing one time. Yeah, it's like you have to count the number of ones initially. Okay, the biggest advantage is we are having only zeros and ones in our string. That is the biggest advantage. Okay, so can I say if I have total ones, of my string, over here it's 0 1 2 3, okay, 4, so there are 4 ones. Now if suppose I am here and I want to divide my string into this 0 1 as left and right as 1 1 0 1. So what is the things which we are concerned of? Count as 0 and count R1, right? So can I say count as 0 is very simple. Till the ith index you can just keep a count of how many zeros you have encountered till now, right? Now similarly, the same way we approached the previous problem, we will use that trick for counting the total number of ones till here. Can I say if I subtract the total number of ones I have encountered till ith index, my count R1 will be total ones that I have, total ones in the string minus the number of ones I have encountered till my ith index, number of ones till ith index, correct? So will it give me the number of ones in the right substring? So over here if we see, this value will be 1, total number of ones was 4, so on its right how many ones we are getting? 3, so it's giving the right thing. Did you all get it? Like it's just similar as that to previous problem. It's just a variation of it. Yep. Okay, cool. So let me quickly write down the pseudo code for this. There will be an answer 0 for sir, practicing DSA is not helping me to crack coding round. If one hacker has problem of a company, कैसे practice करो? Okay, so basically Ritamo.js, like I don't know what's your name is, I think so I'm pronouncing it right. So for DSA thing, it's like two things are very important. First, you should practice many different type of problems, okay, many different. So I would say like once you solve around 300 to 400 problems on different topics of DSA, you will get to know different patterns around it. And most importantly, if you are not able to solve any problem, just don't directly jump up to the solution, okay? Just see where your solution is failing. That's very important to get the intuition like why you are not able to solve that problem, okay? And if suppose that problem is seriously hard and you are not able to solve or come up with a solution while giving all your tries, then you can see the solution and analyze, okay, you have thought till here and this is the point where you lagged, or this is the point where you had to think in some another way. Or if it is a question and something new concept is used over there, then obviously learn that concept first and then try to solve that problem and code it down on your own, okay? Like if you practice this, I am sure that it will help you. Like it has helped me a lot. Yeah, time complexity will be big of n in this approach as previous, okay? Okay, So over here, what we will doing for I equal to 0 until n, okay, from I equal to 0 to n. So I have to, yeah, no problem. So I have to see, because what I said, if I am having this array, so till the ith index I will be having my left substring, and c2, c3, c4, this will be our the right substring, okay. Right, so now we will see if s of I is equal to 0, we have to maintain both the counts. So what is both the counts? I will say I will keep a count of left zeros, okay. I will keep a count of left 1 as well to get this at ith index, and count r0 is like count r1 is simply which we can get using this formula, okay. Right, so over here, if my si is equal to 0, then what I will do, I will simply increase my count of left, else I will increase my count of left 1. And how I will get count r1? That will be total ones, okay. I will be denoting by t1, total 1, minus count l1, okay. And what will be my answer? My answer will be max of answer comma count l0 plus count r1, okay, and we will simply return an answer. So over here, all the operations over here are constant time, and this will run for n times. So our time complexity is big of n, right, and the space is big of 1, because we are not using any container or any space, that sort of, okay. Let me know if this is clear to everyone. Okay, cool. So I will just code it down as well. So let me just comment this out, as we have to take a string. So I'm taking a string, find max score. Let's keep our function as this, find max score. And yeah, always one more thing, like whenever you are writing your code in an interview, then just try to keep your helper function as descriptive as possible, okay. So find max score, and what will be passed? I will pass my string. My string is, okay. Let me just erase it. Okay, so I will pass a string over here, and this will be my answer. I will now, what all variables I require this answer equal to 0. First of all, let me just get the length of the string, okay. My answer is 0, and what all I require, int count l zeros, left side में कितने zeros हैं, that will be 0. Count l1, how many ones I have encountered in my left substring right now, that will be 0 right now. And count, okay, count r1 will be simply, we'll be calculating over there, so we will simply just declare it, okay. And there will be a variable where we will be taking total ones, total 1, and I will initialize it 0. And firstly I will traverse from 0 to n, and I will see if ith character is 1, total 1, increment the count. Now I have got the total 1. Now comes the logical part, or the algorithm I should say, which we discussed, okay. So it will be for int I equal to 0 till n, okay. And what I should do, I should increase my count L1. Oh, sorry, if it's equal to 0, then I have to increase my count L L0 plus plus. Else, if it's a 1, then simply count L1 plus plus. And how will get the count R1? Total 1 minus count L1, right? And what will be our answer? Our answer will be max of answer comma count number of zeros on left plus number of ones on its right. Total minus count L1. No. Yeah. Total minus count L1 will be able, like, by that we can calculate a number of ones on its right. Okay, and we will simply return this. Yeah, everything is perfect, I think so. Now let me 0 triple 1 0 1. I think so. This was our string. Let me run it and see. For this, 5 was the answer, right? Yeah, 5 was the answer for this. Yeah, so we are getting the answer as 5. And let's take some another example as well. Let's take this 00 triple 1. Double zero. Okay, I have to 00 triple 1. For this, the answer should be, what should be the answer? I think so. This point is the most beneficial one. So 3 plus 2, 5. Again, 5 should be the answer for this. Yeah, so 5 is our answer. Okay. So I hope you all have got the solution to it and understood. This is a very important concept, and like you can use it many places. There were 2 variations of this which was asked in Walmart interviews, so I picked these questions. Okay, thanks AP, thanks. I hope you all enjoyed the session and hope you got to learn something. Thank you everyone for attending the session, and do like, share and subscribe so that for the upcoming classes you will get notified. Okay, thanks a lot everyone. Or if anyone is having any doubt, I am here, like they can ask. Yeah, ask me. For gate, basically, see, in gate you encounter output problems much more. Okay, but yeah, DSA is very important for gate as well. Despite your core subjects, DSA also come, but coding things doesn't come like you are given a problem, you have to code it. They're mostly output questions comes. Okay, and those are those problems comes in C programming language. Okay, okay, see, having a good grasp at DSA always helps you, what I have found. Okay. Anyone else who like I don't have any single project? See, if you are preparing for gate, I don't think so you need any project sort of thing. It's good like if you have a project, it's very good, because if you're having an hands-on experience on any of the technology, it always gives you a leverage in interviews. Okay guys, so I think so we can wrap up. Yeah, no worries, AP. Thanks a lot everyone again for attending the session.